Hey, what's up guys? The video you're about to watch is one of the labs that I'm creating on KBTrainings.com for the course on Cisco CCNA 200-301. It's a master course that goes from zero to engineer. I teach you everything you have to know to go, take, and pass the Cisco CCNA certification exam with flying colors. So if you like the video, like it on YouTube, and if you want to see the full course, go on KBTrainings.com. Thank you and enjoy the video. Today we're going to do some QoS configuration, and I need to tell you that Cisco doesn't require you to do the configurations. We saw classification, marking, congestion management, queuing, traffic shaping, traffic policing. You're supposed to know all of this in theory, but I think it's better for you if you can see how we can configure these or some of these in a lab. And we are also going to master the MQC, or the modular QoS command line interface that is used to apply or to configure QoS on Cisco devices. So we're going to see all the different elements of MQC. So we are going to do these few things here. As I said, we're going to understand MQC and concept like class map, policy map, and service policy. We are also going to change some packet DSCP. I'm going to show you how you can change the priority of a packet. And we're going to play with traffic policing or traffic shaping and traffic shaping. So I'm going to do a lab in GNS3. This is our lab or our topology we're going to cover today. I'm going to use Ostinato. For those of you that are not familiar, Ostinato is a tool that is going to help us create packets. So we're going to create a flow of packets going through this network, and we're going to see how we can apply QoS on this router over here. So basically, our topology today has a router here, router 1, that is connecting two networks, 10.0.0.0 and 10.0.1.0/24. So on this side, we have the PC1. This is going to be our destination for all the packets that we're going to generate in this network. And here we have a switch that is just connecting these two devices here. This is Ostinato number 1, and it's going to send packets with the IP of 10.0.0.2. This is Ostinato number 2 with 10.0.0.3. And I put two of them because I want to generate two types of packet. This first one will only generate voice packet with the DSCP of EF as a regular voice packet. And here we're going to generate ICMP, and I'm going to send those and see what we can do with this. So this is going to be 60 kilobit per second of voice. And down here, we're going to have 30 kilobit per second of ICMP. And one of the things I'm going to test here with you is to reduce the bandwidth or to configure some traffic shaping or traffic policing on here, and to see how with 40 kilobit per second, we're going to drop some traffic, and we're going to see which traffic is going to be dropped. Is it going to be voice or ICMP? All right, guys, that's all for this quick QoS lab. Oh, it might not be quick. We'll take all the time necessary. So let's go in a router and do some basic configuration in here. The router is already up. Let's see what we have under the interfaces. Let me increase. So show IP interface brief, just to see what we have on the interfaces. We don't have any IP addresses or anything. So let me configure the interfaces. The first one is interface gig 00. Here I'm going to give it the IP address of 10.0.0.1/24 and no shut. And then I'm going to configure the second one, 10. I will give it the IP address of 10.0.1.1/24, no shut. All right, that's all for the routers. So show IP interface brief. You can see that we have our two interfaces here that are up. So I just configured this one, 00 and 10. So I'm going to configure the PC1 as well. Let me get access to it. And I will give it an IP 10.0.1.2/24 with the default gateway of 10.0.1.1. All right, it's checking for duplicates. We don't have any. Let me try to ping 10.0.1.1. It's supposed to ping without any problem. All right, we are good. And then that is all for this side of the network. Let's go ahead. I don't have to configure the switch. It can be just the standard switch. All the ports should be in the same VLAN. Let's check what we have here. Show VLAN brief. It looks good. All the ports are in a VLAN number 1, the default VLAN. So let's open our first Ostinato device. This is what it looks like. This is the Ostinato screen where we have the different interfaces. The Ether 1 or the port 0 is the one that is connected to the switch on both of these devices. So this is where I'm going to create a stream. So to create a stream, I'm going to go under stream, new stream, and then this one I'm going to call it voice, because as I told you, this is going to be for voice devices. I mean, for voice traffic. The packets or the frames are going to be fixed. I will give them 1 or 1300 bit. So layer 1, we're going to have MAC. Layer 2, it's going to be Ethernet, no VLANs or anything like that. Layer 3, it will be IPv4. Layer 4, it's going to be UDP because we're talking about voice here. The pattern, I will just leave it by default, and we go to the second tab. The destination MAC address needs to be the MAC address of the router here. So I'm going to go in the router and grab the MAC address of the port that we are connected to. And to do that, I'll do show interface gig 00. And this is the MAC. I'm going to copy the MAC on that destination. All right, that is the destination MAC address because our packets will have to go all the way to the router to be sent to the other network. So the source MAC needs to be fixed as well. And I'm going to do anything here. I can do 01, for example. This is good enough for the router to know where we are and to send us the packet. Ethernet or layer 2, we don't have much to do here. Layer 3, we need to make sure the source is 10.0.0.2. This is the IP of this Ostinato where we're going to send the packet from. And the destination will be 10.0.1.2, the computer we have on the other end. And then I'm going to set the DSCP to EF, which is for voice. And that should be it here. For the user diagram, I have not much to do. The payload can stay just this bunch of 0. Variable fields, we don't have anything to change here. Stream control, this is where the number that is important is the bit per second that we have here. I want to have at least 60,000 bits per second. So I can change how many packets I send every second. Let's try 6. It's going to give us 63. Let's even try 7. So we have, 8. So we have about 80 kilobit per second. And what do we do after the stream is over? We're going to go back to the first. So it's going to be an infinite loop generating packet for us. And then I would just do OK and apply. So that should be it. But before starting the stream, what I'm going to do is launch a packet capture here with Wireshark. So let's see what we have on this link. There's a new version, not now. So I'm going to make sure all of these are not. What is trying to get an IP here? Is it my Ostinato? I'm not sure. But I'm going to filter out all of this. So let's do this. So filter as filter not selected. Next one, spanning tree, filter, apply as filter and not selected. CDP, apply as filter and not selected. What is this? Configuration test protocol, apply as filter and not selected. DTP, apply as filter and not selected. So we have this filter here that we're going to apply on the other side as well. So this is the side going from the switch to the router, and I'm going to launch another packet capture here from the router to the computer that we have on the other end. So I'll just apply the same filter that I copied from the other end and apply it here. So we have nothing beside whatever we're going to generate from Ostinato. So from here, I'm going to go back to Ostinato and then hit start transmit. You can see here, you're going to see here, we're going to have some packets being launched from there. So when I do this, all of a sudden we have a bunch of packets being sent. And if I go back to Wireshark, you can see we have voice packets and the computer on the other end is also responding. If you want to take a look, this is going from the Ostinato to the computer, and it's of course UDP. The layer 3 we can see DSCP is EF per hop behavior. So this is for our voice packet. So this is from the router to the computer, and on this side we have the traffic from the switch to the router. So we are all good. I can go back and take a look at this interface here. If I do another show interface gig 00, you can see that the rate is now increasing because we have traffic coming in. And I feel like we don't have traffic going out. Why is this 0? Oh, no, we should have traffic going out as well. Let's see. We only have it on one end, but it's responding. This is actually, oh, on this side, on the side from the switch to the router, I feel like there's no traffic coming back. Something is off here. Let's check what's going on. Show IP routes. Show IP routes. We know where 1 is and all of that. Or maybe it doesn't know. Or show ARP. Show ARP. It says incomplete. I don't know why. So let's go under network and give this 10.0.0.2, 10.0.0.1. Oh no, broadcast, it's supposed to be 255, and then 10.0.0.1. So you need to put the same IP on the Ostinato interface so you can receive the packets back. So now if we do the show IP or show interface gig 00, we can see that we also have output rate that is being increased. That is very good. So let's go and start generating the packets on the second Ostinato. The second is for ICMP. So I'm going to create a new stream on this port, select the port, go under stream, new stream. I'm going to call it ICMP. And layer 1 MAC, layer 2 Ethernet, layer 3 IPv4, layer 4 ICMP, and that's it for this. We're going to the next tab. Oh no, I need to change the size of my frames to 1300 bit. Data, here we're going to put the MAC address of the router. Okay, we also need to have an IP on the interface of this Ostinato. So I'm going to go under network and make sure I put 10.0.0.3 and then default gateway 10.0.0.1. That should be enough, and then apply. So the destination should also be fixed. I can give it anything. I can do 02 here. It will be fine. Layer 2, not much to do here. Layer 3, we're going to have CS0 of ICMP. So it's going to be from 10.0.0.3. Destination will be 10.0.1.2. And this should be it. ICMP protocol, not much to change. Payload, no change there. Variable fields, we have nothing to change. The packet, we're going to make sure we have about 40 kilobit per second. So let's do 4. We're going to have 42. Let's do 5. No, just 4 is enough. All right, so when we finish, we go first. So it's going to be a loop. The packet view, if you want to see what it looks like. But we are good to hit OK and apply. And then we can hit here and start streaming. So if we look at a Wireshark, we can see that we have ICMP packet as well as, let's see, something is wrong with the ICMP. No SYN. Apparently there's no response for ICMP. Let's check the packet coming from here. So we only have the voice. Here we have voice and ICMP. So let's see what is wrong. The router show ARP. Oh, I made a mistake on the destination. It's supposed to be 10.0.1.2. Let's go back and fix it. So is it the voice or the ICMP? So I'm going to edit and make sure the layer 3, we have 10 here. Okay, so that's why we couldn't receive responses. So if I hit OK and apply, please stop the stream before applying. Okay, we can stop the stream and let's make sure the change is in. Okay, so we hit OK and apply. And now we can start a new stream and we should be receiving responses for ICMP as well. Let's see. Yes, we have requests and replies. Okay, now it's a little more even. We can see ICMPs followed by UDP or voice traffic. Okay, and if we look at the interface, we can do show interface gigabit 00 summary. So here we can see that we are receiving 124 kilobit per second and we are sending 91 kilobit per second. We can also just wait a little bit, and this number is supposed to be equal because we are sending as much as we are receiving. So after a while, we have 124 for both transmit and receive. So now everything should be working as expected. We have 124 kilobit per second coming from these two devices here going into the router. So now we're going to do some QoS configurations. I'm going to change the DSCP value of the ICMP packets only. For now, I'm not touching the voice. We'll do the voice sometime later. We can maybe, we do the voice only with the traffic shaping on this interface. So right here, I want to make sure that when ICMP or an ICMP packet comes in, right now it has a DSCP of CS0. We can increase it or lower it as we want. So right now I'm going to change that value to something else before sending the packet to the next node. So that's what we're going to do. And to do that, let's go back inside the router. And what I'm going to do, let's verify that first. Let's verify that we have ICMP with CS0. So if I stop here, I grab one ICMP packet, look at the layer 3 DSCP CS0. And on the other end, this is going from the switch to the router, as you can see. So on the other end, from the router to the computer, I can also stop here and grab ICMP. It's still CS0 for DSCP. So let's go ahead and change that. And this is where we're going to apply the MQC that I told you about, the modular QoS CLI. First of all, we need to create what is called the class map. The class map is going to define what is the traffic we are targeting. So to create that, you go under the config mode and do class map. I'm going to call it ICMP. But before moving forward, you can have more than one conditions inside the class map. Here we're going to have only a single condition, so it doesn't really matter. But if you have more than one condition, here you can determine if your class map need to match all or match any of your conditions. The match all is the AND logic. So you need to match both those conditions at the same time for the class map to apply. And the OR, you need to match any of those conditions. So in our case, as I said, we're gonna have one condition inside, so it doesn't really matter. So I'm going to do class map named ICMP. So inside, I'm going to use the N bar to select the ICMP, N bar or network-based application recognition. So to do that, we need to do match, and here we can pick any of these options. So I'm going to go with protocol because that is N bar, and then I will pick ICMP. So when I do that, it's going to take a moment. So let's wait for N bar to identify ICMP. Okay, so that is all for now. And if we do show class map, we can see that we have one class map here called ICMP, the one that we just created. So if you don't select anything for the match all or match any, match all is the default that you're going to have set. So here we have match all, but we just have a single condition inside here. So we are matching ICMP with this. And by default, we also have the class default that is coming with the device. And this one matches anything else that is not matched by another class map. So after creating the class map to catch the ICMP, the next step is to create the policy map where we're going to say what are we going to do to the traffic that we are capturing with class map. So we need to exit here. Let's just exit and do policy map. and I'm going to call it ICMP still, because it doesn't matter. It's different from class map, so they may have same name. It's not a problem. So when I go inside the policy map, I need to determine what class map I need to apply the policy map on. So I'm going to apply it on the class called ICMP that we just created. And then inside, what are we going to do? I'm going to set DSCP to which value. I can pick any of these. Let's set it to CS6, for example. CS6, let's make sure it's CS6. That's it. Okay, so we just said that everything that's coming in with ICMP, we're going to set the DSCP value to CS6. Or let me pick something else. So let me pick something else different from the CS. Let's take AF11. So I'm going to do set DSCP AF11. All right, so we have our class map and the policy map in place. If I do show policy map, we just have this policy map that is applied to the class map ICMP, and we are going to set the DSCP to AF11. So now we need to apply this on an interface, and we know that the interface we want to apply this on is the incoming traffic on gigabit 00. So we're going to determine that inside the router by doing conft to go under the config mode, go on the interface gigabit 00, and here we're going to use the command service policy. And is it going to be applied to the input or output? In this case is input, and then we're going to give the name of the policy we want to apply, ICMP, and after that it should be all. We just hit enter, and now we are changing the DSCP. So this one is going from the router to the device. Let's go here and grab one of the latest ICMP packet. Let's see. So it's this one here. We can see the DSCP is now set to AF11. So this is what we just did inside the router, and the router is changing the priority or the DSCP value of everything ICMP. If we take a look at voice still has EF as it was before entering the router. So that's how we can increase the priority of a packet. So the next thing I want to do is, as I said, I want to do some traffic policing over here. I want to reduce the bandwidth of the traffic coming out of here by doing the traffic policing. So to do that, let's go inside the device. First of all, we need to create a class map. Okay, so we want to capture both voice and ICMP, only those two flows, and reduce the bandwidth for those two to 40 kilobit per second. So what I'm going to do is create a class map first. So I'm going to call it class map, but make sure that you are selecting match any, because we're going to have two conditions inside of the class map. So it's going to be match any, and I'm going to call it police because we're going to do some traffic policing. So inside, I'm going to match everything with a DSCP of EF. This is going to match our voice packet, and then I'm going to use N bar again to match ICMP. Okay, so we have those two conditions, and we can then create a policy map. I can call it police again, and I'm going to apply it to the class named police. And here, what do I want to do? I want to police. Let's look at the commands that we have here. So we have bandwidth, we have police. I'm going to pick this one here, the police command. So I'm going to do police, and what do I want to be the target bit rate? In my case, I want to have 40,000 bit per second. And I'm not going to configure the confirm bars and anything else. I'm just going to go straight to the confirm action for all the packets that are going to be, or all the traffic that is below 40 kilobit per second. What are we going to do? So the confirm action is to transmit. And then next we have what is called the excess action. So if anything exceed that, what are we going to do? We're going to drop it. See the options that we have here. We're going to drop it. And then everything that is also violating whatever we are setting here need to be dropped as well. So that is it. And if I do that on the output interface, check 1/0. We can see that on 1/0, we still have the same 124 kilobit per second, and we are not dropping any packet. If you look here, OQD means the packet dropped from output queue. This is the output interface. So we are going to be dropping some packets to make sure that we have 40 kilobit per second over here. So let's go ahead and do that. So I'm going to go on that interface, conft interface gigabit 10 service policy, outputs, and then the name of the policy map, police. And that's it. When we apply and we go back, let's see, we are dropping packet already. As you can see here, we've already dropped 32 packets, and I can still refresh the result. You can see we are dropping packets, and the transmission rate is now dropping to 116 kilobit per second. It's going to drop all the way to what we set, which is around 40 kilobit per second. Let's give it a moment, and we're going to come back to this and see what we have. But meanwhile, we can still go beyond the router over here to see what are the packets that we have on this side here. So let's go ahead and try that. So this is the packet, the packet capture going from the router to the, you can see here we have no ICMP anymore, or we have rarely ICMP, because ICMP is heavily dropped because it has low priority. So as you can see, we have a lot of voice, less ICMP. And if we want to see what is the queuing mechanism being used by this device or this interface, you can see here that we are using FIFO, first in, first out. Okay, but we just have too much UDP coming, and too much voice coming, and that's why we have way more voice than ICMP. So I'm not going to play with queuing. I think this video has been long enough. That's probably going to be it for today, guys. Or I can just wait a little bit to see how the rate is going to drop on that interface. Okay, so after a while, we can see that the rate dropped at 38 kilobit per second, and this is what we wanted. This is traffic shaping in action, and we are dropping a bunch of packets. We're dropping a lot of packets. Cisco doesn't require you to do the lab, but it's always good to go a little beyond what is required so that you get some good idea of what we're talking about here. If you don't have Ostinato, which is actually available on GNS3, you need to buy the image though. The image is about $30 online. If you have it from wherever, you can just use to build Ostinato. If you don't have GNS3, if you don't have Ostinato, you can still use Packet Tracer and just find a way to change the DSCP and do all kind of manipulations with QoS. All right, guys, that's all for this video. Thank you for watching. If you like the video, like it on YouTube, and also subscribe to the channel if you haven't, so you will not miss any of my future videos. Follow me on Facebook, Instagram, and Twitter to stay in touch. And again, this is from the CCNA course on KBTrainings.com. Go there and check it out. Thank you, and I'll see you in the next one. Bye.